Good afternoon, everyone. This is NextShow's OneRecord Top Gun team presenting our solution for the IATA's OneRecord Hackathon 2023 at Frankfurt. Thank you, IATA, for this wonderful opportunity and Lufthansa Cargo for providing us with such an amazing environment. Thank you, judges, for sparing your valuable time in spite of your busy schedule to evaluate our solution. We are positioning our solution under the following challenges. The first challenge being sustainability, where we use artificial intelligence for optimized ULD utilization, reducing waste and promoting reuse. We are also trying to address the cargo IQ challenge, where we use IoT for end-to-end real-time visibility, data quality, and timeliness. We are also going to use predictive analytics for risk assessment and mitigation, making it as a candidate for the open challenge. Let me introduce our team. Here we have Varun, who is a bachelor's in computer science, and his interest lies in blending the power of AI with MERN stack wizardry and creating intelligent web experiences. We have Vishwas, who is a bachelor's in electronics and communication. His interests lie in transforming ideas into interactive experiences, crafting dynamic web solutions with MERN stack. Here I am, Rama. I have a PhD in information systems, and my interests lie in driving technological excellence, orchestrating innovation, and empowering digital transformation. In our interactions about ULD management with various stakeholders in the air cargo supply chain, we observe certain challenges regarding sustainability. We observe challenges with respect to the lack of standardization, limited ULD tracking systems, high maintenance and repair costs, and lack of data and metrics. We also observe certain challenges in getting end-to-end visibility on a shipment or ULD as it goes through the various stages of supply chain. The challenges include implementation inconsistencies, data quality and timeliness, cost and resource constraints, and lack of real-time visibility. While trying to analyze the problem, the following questions came up. Can we use IoT to provide real-time visibility and proper monitoring of ULDs? How about measuring information like temperature, pressure, humidity, light, etc. to confirm the impact on quality of shipment in those ULDs? Can we measure the shock magnitude and use machine learning and neural networks to predict probability of failures and alert users to take corrective action? How do we use the geolocation information from IoT devices to provide end-to-end visibility of cargo? What if we use IATA's interactive cargo concepts and benchmarks natively integrated into OneRecord to achieve all of the above? Our solution, TRULD, tries to find answers to some of these questions. Let us see TRULD in action. You can access the solution from the URL frahackathon.nextshow.com. Our solution uses the following APIs and servers. It uses NextShow's IATA OneRecord API server and database for storing and retrieval of logistics objects and IoT data. It uses Neon server for information on logistics objects. It uses Honest server for retrieving real-time IoT information.
This is the login page. For the purposes of this demonstration, we have pre-filled the email address and the password fields. Once you log in, you'll be redirected to our main dashboard page. Here on the top, we have 3 widgets currently in use, in storage, and ULDs at risk. And below here, we have a map which shows the live location of all the ULDs that are associated with this account. And we also have a provision to switch between a light mode and a dark mode.
The third widget on the right displays the number of ULDs at risk of failure. The risk of failure is something we compute by feeding information from our IoT devices into an artificial neural network. We employ a sequential neural network with 2 dense layers for this purpose that we built using the TensorFlow library. The model is trained based on the data that the user of the application generates, meaning that we can predict failure for various types of containers with a high degree of accuracy without actually having access to the data beforehand. This is incredibly useful when you consider the variety of ULD containers in use with varying stress limits and tolerance to extreme conditions.
When we click on the live location of any particular ULD on the map, we display a pop-up which shows the serial number and the percentage of risk associated with that particular ULD. When we click on the View More Information button, we are redirected to a new page which shows various details associated with that ULD which were captured through sensors, such as the shock, temperature, pressure, and humidity. On the top of this page, we have a button which displays a map which brings end-to-end visibility on ULDs. It does this based on real-time data from IoT sensors. It charts the path that the ULD has taken through its supply chain journey. In the sidebar, we also have a tab which shows in a tabular format all the ULDs that are being tracked by the user.
TruLD from Nextshore uses neural networks to predict failures, enhance sustainability in ULD management, enables real-time tracking of ULDs by using IoT data, brings end-to-end visibility to the journey of cargo.